right, let's jump right in. Coding in 2025. Wow, it feels like it's changing almost daily, doesn't it?
It really does. And this term vibe coding keeps popping up.
Exactly. Vibe code. It sounds a bit fuzzy maybe, but it really just boils down to using natural language, like plain English, to tell an AI tool what code you need.
Right. And the AI then, well, generates it for you. Andrej Karpathy had a great line for it. Something like,
Oh yeah, see stuff, say stuff, run stuff, and copy-paste stuff, and it mostly works. That kind of captures the essence, I think.
it does. And you can see the appeal, especially for, anyone listening who wants to get up to speed quickly in tech.
Right. Maybe you're prepping for a meeting or just trying to stay current, or you're simply curious. This seems like a way to grasp things fast.
Definitely. A way to see ideas become code without getting totally stuck in the syntax weeds right at the start.
And that's really what we wanted to explore in this deep dive. We've looked at a bunch of sources articles from places like Zencoder, Unite.ai, Pixel Matters, IBM, Sonar, NewCamp.
And even a really active Reddit thread, our chat GPT coding. So a good mix of perspectives.
Yeah, from the industry side and from developers actually, doing this stuff day to day.
Which is great because it lets us look beyond just the hype.
Right.
Get into the practical side of vibe coding. What's the promise? But also, what are the real challenges?
Exactly. So our mission today, explore the cool stuff, the potential benefits for sure, but maybe more importantly, focus on the risks, the potential pitfalls.
Especially thinking about entry-level to mid-level programmers, maybe? And anyone just generally tech-curious who's hearing this term?
Yeah, what does vibe coding really mean for you?
Well, thinking big picture, it could genuinely shift how software gets built. The appeal is pretty clear.
Oh, absolutely. Faster development, right. Making coding feel more accessible if you're new.
Yeah, turning ideas into prototypes super quickly.
And people are using it. I saw a stat. Something like 92% of U.S. developers are already using AI coding tools.
92%. That's not niche anymore. That's mainstream.
Right. The idea you can just say, make a button, and when I hover, make it turn blue, and boom, an AI like ChatGPT or Copilot or Claude.
Or Cursor, V0 from Vercel, Replit. There are quite a few now.
And they spit out working code. That's incredibly attractive, especially if you're like just starting your coding journey.
That lower barrier to entry is huge. Learning to code traditionally takes, a big upfront time investment in syntax and concepts. Vibe coding lets people experiment and build much sooner. That can be really motivating.
And here's the big but, right? All that speed, that easy entry, does it come with a cost down the line? Let's talk technical debt.
Ah, yes. Technical debt. It's a crucial point. If the focus is purely on speed, are we trading off long-term code quality, maintainability?
So explain that a bit. Technical debt is basically what cuts.
Yeah, essentially. You make choices. Now maybe take a shortcut, use a solution that's quick but not ideal to get something working fast. But those choices make future work harder, more expensive, more time-consuming. And the worry with vibe coding is that while it makes code generation easier for everyone, it might also make accumulating technical debt easier, maybe even faster, and on a bigger scale than before.
Right, creating future problems without even realizing it. So what would that look like? What are the signs?
Well, you might see inconsistent code patterns because different prompts to the AI could result in slightly different ways of doing the same thing.
Okay, yeah.
Documentation might suffer. If you're just prompting, are you taking the time to document why the code is the way it is? Probably not as much.
Let's focus on the why.
Exactly. And you might end up with quick fixes from the AI that just aren't built to last, not maintainable. Ben Larica mentioned this earlier this year.
From gradient flow.
Yeah, he said AI-generated code often lacks the structure, the docs, the clarity you need for the long haul. It means potential rework later, costly rework.
And how does that impact the whole project lifecycle?
It ripples through everything. Maintenance costs go up because developers are spending time figuring out this maybe messy, maybe undocumented code.
Right.
Bringing new people onto the team gets harder if the code base is confusing.
Makes sense.
And eventually, that initial speed boost you got from vibe coding, it can completely evaporate.
Yeah.
You end up spending all your time fixing things instead of building new features. There was a Coding IT blog post about teams just running in circles fixing AI-generated messes.
Oof. Okay, so for people listening who are maybe using these tools or managing teams using them, how do you stop this from happening? What are the practical steps?
Mitigation is absolutely key. First, code reviews. They become even more important.
But specifically looking for AI-introduced issues.
Exactly. Looking for inconsistency, lack of structure. Second, track the debt. Use tools like SonarCube or maybe Debt Track to make the debt visible so you can actually manage it.
Okay.
And finally, plan for cleanup. Schedule specific time like refactoring sprints dedicated just to improving the code base, paying down that debt before it gets out of control.
Right. Be proactive about it.
Mm.
Okay, so technical debt, that's a big one. What's another major risk area we need to think about with vibe coding?
Security. This one is, well, it's potentially the most critical.
Why is that?
Because AI models, they learn from patterns in vast amounts of code. But they don't understand security principles deeply. They predict the next likely bit of code, but they don't inherently know if that code is safe.
Ah, okay. So it might look right, but be insecure.
Precisely. It might generate code quickly, but that code could have vulnerabilities baked right in. Things like how it handles user input or errors or external
So what
libraries.
kind of common security flaws might pop up in AI-generated code?
Several usual suspects. Input validation is a big one. If the AI doesn't generate code that properly checks and cleans user input, you open the door to things like injection attacks.
Right, classic stuff.
Error handling might be too generic. It might accidentally leak sensitive system details to an attacker if something goes wrong.
Oh, interesting.
And dependencies. The AI might pull in third-party libraries, maybe older versions that have known security holes, without any warning. Analytics India magazine had a story about someone whose AI-built app got attacked almost immediately. Wow.
And Santiago Valderrama put it bluntly. He said, AI code can be full of security holes.
Yeah.
It really underscores the risk.
Yikes. Okay, so the consequences. What are we talking about?
Pretty severe stuff. Data breaches, obviously losing user data, financial info. That leads to huge legal trouble, fines.
Compliance issues too, I bet.
Absolutely. If the code doesn't meet security standards like PCI DSS or IAP, and then there's reputational damage, a big security breach can destroy user trust.
Okay, definitely serious. So how do we prevent this? If we're using vibe coding, what are the defenses?
Prevention is vital. First, automated tools. Security scanners like OSPZAP, SNCC, SonarQube has security features. Run these constantly on the AI-generated code.
Catch things automatically.
Yes. Second, human review, but specifically security-focused code reviews. Get experienced eyes looking for those potential weaknesses.
Right.
And third, training. Make sure developers using these tools are trained to recognize common vulnerabilities, even in code they didn't write from scratch. They need to be able to spot the risks. Gotcha. Okay, so tech debt, security. Moving on, that about growth. Can these apps handle more users, more data over time? Scalability.
That's another really important consideration. Vibe coding is often great for getting that first version, that prototype, out the door fast, but the focus is often just on making it work immediately. Less thought might go into the underlying architecture needed to handle, say, 10 times the users or 100 times the data.
So it works fine for a demo, but breaks under load.
Potentially, yeah. The application might struggle to scale efficiently.
What kind of specific challenges would you see there?
You might see inefficient resource use. The AI chose a simple path, not the most performant one, so it eats up more server power.
Okay.
Database queries might be slow or poorly optimized because, again, the focus was on initial function, not performance at scale. And there can be a tendency towards monolithic designs where everything's tangled together. That makes it hard to scale just one part of the app that's under heavy load. Index.dev actually called this out, that rapid generation can lead straight to scalability problems later.
And the business impact of that. If your app can't scale,
It's pretty direct. Performance tanks, users get frustrated, maybe leave.
not good.
Cloud costs can explode if you need way more resources just to keep the inefficient code running. And ultimately, it just limits how much the business can grow if the tech can't keep up.
So what can engineering teams do if they've got a vibe-coded app that's hitting scaling walls?
There are solutions. First, define and enforce performance testing. Test early, test often under realistic load. Find bottlenecks before they become critical.
Proactive testing.
Definitely. Consider architectural patterns like microservices. Breaking the app into smaller, independent pieces makes it easier to scale just the parts that need it.
Makes sense.
And conduct specific design reviews focused purely on scalability. Think about database access, caching, resource leads before you're in trouble.
Right. Plan for scale from the start, even if you're using AI to help build.
Mm-hmm.
Okay, beyond performance and scale, what about just living with the code day to day? Maintainability.
Absolutely crucial, and sometimes overlooked in the rush for speed. Long-term success depends hugely on how easy it is for developers to understand, modify, and fix the code.
And vibe coding can hurt that.
It can, yeah. If the focus is just on generation, you might not get code that's well-structured, clearly written, or easy for another human or even your future self to maintain.
What are the warning signs?
Good point.
There are red flags for poor maintainability in vibe-coded projects.
You might see high cyclomatic complexity. That's basically code with lots of nested if statements or loops, really hard to follow the logic.
Okay, tangled logic.
Duplicate code is another one. The AI might generate similar blocks of code in different places if prompted similarly instead of creating a reusable function.
Right, copy-paste on steroids.
Kind of, yeah. And unclear naming. If variable and function names generated by the AI don't make sense or are inconsistent, navigating the code base becomes a nightmare. Ekingai.com had an article pointing out this exact trade-off. Vibe coding can give you short-term productivity, but cost you long-term maintainability.
And the long-term pain if your code is hard to maintain.
It adds up. You get knowledge silos. Maybe only the person who originally prompted that bit of code really knows how it works.
Risky if they leave.
Very. Bug rates tend to go up because making changes in complex, poorly understood code often introduces new problems.
Yeah, I can see that.
And honestly, developer frustration. It's demoralizing to fight with a tangled, messy code base day after day. It can even lead to people quitting.
So how do teams avoid this? What are the best practices for keeping vibe-coded stuff maintainable?
You need discipline. Enforce coding standards rigorously. Refactor the AI's output to meet those standards. Don't just accept what it gives you.
Human oversight again.
Always require good documentation. Not just what the code does, but why it was prompted that way, what the intent was.
The context is key.
Exactly. And techniques like pair programming can be really valuable. Two developers working together on the AI-generated code, understanding it, documenting it, refactoring it. That shares knowledge and improves quality.
Okay, good strategy. So we've hit tech debt, security, scalability, maintainability. What about testing? That's fundamental, right?
Absolutely fundamental. And vibe coding introduces some specific testing challenges, too.
Like what? What gaps might appear?
Well, first, just insufficient test coverage. If developers don't fully grasp the nuances of the AI code, they might not write tests that cover all the important scenarios or edge cases.
They don't know what they don't know about the code.
Precisely. You might also see inconsistent testing approaches if there isn't a clear team strategy for how to test AI-generated components. And there's a temptation, maybe, to rely more on manual clicking around rather than building robust automated tests, because understanding the code well enough to automate tests for it takes effort.
And the impact on quality if testing is weak.
It's predictable, unfortunately. More regression bugs where fixing one thing breaks another.
Ugh, regressions.
Release quality becomes unpredictable. You push code out, hoping for the best, but maybe finding nasty surprises later. And QA cycles can get much longer as testers try to manually cover all the bases.
So how do we ensure good testing discipline with vibe coding?
Frameworks and process help. Adopting test-driven development, or TDD, can be powerful.
Right.
Write the test first, defining what the AI code needs to do, then generate the code to pass the test.
Test defines the requirement.
Exactly. Also, robust continuous integration, or CI pipelines, are essential. Every change, including AI-generated code, should automatically trigger a full suite of automated tests.
Gatekeeping quality.
Yes. And set clear expectations. Define minimum code coverage requirements. Say 80% of lines or branches must be covered by automated tests to ensure critical parts aren't being missed.
Okay, that makes sense. We've covered a lot of the potential, well, the scary part.
The risks, yeah, they're real.
To get a bit more balance, we checked out that Reddit discussion you mentioned, our ChatGPT coding. What were the vibes, pun intended, over there?
It was actually a really good snapshot of developer sentiment. On one hand, lots of enthusiasm, people reporting massive productivity gains, some saying 10x, even 100x faster.
Wow, 100x.
Yeah, pretty wild times, but the excitement about speed was definitely there. But on the other hand, lots of caution too.
Okay, like what?
A big worry was that relying too much on the AI stops you from really understanding the code, the fundamentals.
The Feynman quote.
Exactly. Someone brought up Richard Feynman's "What I cannot create, I do not understand." That really hit home for many, the danger of just copy-pasting without comprehension. Others pointed out that debugging and maintaining AI code, especially on bigger or more complex projects, can actually be harder than maintaining human-written code sometimes.
Interesting. Why harder?
Maybe because it lacks that human intentionality or follows patterns that are statistically common but logically awkward for a human to trace.
Gotcha.
And several people made the point that writing a good prompt, one that gets the AI to generate exactly what you need with all the constraints, well, that can be almost as complex as writing the code yourself.
Right. The skill shifts to prompt engineering.
It does. There was also a sense that AI is a tool, a powerful one, but you shouldn't become dependent. You still need your core skills. And that often, to write a good prompt, you already need a pretty solid grasp of the problem you're solving.
So it doesn't replace thinking.
Not at all. And a final concern was just the sheer volume of code AI can produce. Some worried about ending up with mountains of code that become incredibly difficult to debug and manage. There was even some talk about how this might change the developer role itself in the future.
Yeah. That's a whole other deep dive, maybe. So the Reddit takeaway is useful, powerful, but handle with care and keep your brain switched on.
That sums it up pretty well. Enthusiasm tempered with healthy skepticism and a focus on fundamentals.
Okay. Stepping back a bit, there are also some wider issues, right? Legal stuff, ethical questions.
Definitely. And this area is still pretty murky, honestly. Intellectual property is a big one.
Who owns the code?
Exactly. In the US, for instance, the current thinking is that code generated solely by AI might not be copyrightable by a human. So ownership can be ambiguous.
Hmm. That could get complicated.
Very. There's also the risk of license contamination. The AI learned from vast datasets, including open source code with various licenses like the GPL.
Ah, so it might spit out code that has usage restrictions you don't realize.
Potentially, yes. And the tools don't always clearly attribute where code snippets came from or what licenses might apply. Liability is another open question. If the AI generates code that infringes copyright or violates a license, who's responsible?
The user,
Yeah.
the AI provider, still being figured out.
Largely still being figured out legally. And just a practical point, be cautious about feeding proprietary or sensitive company information into these AI tools as prompts.
Good reminder. Okay, now IBM had an interesting take, connecting vibe coding to agile development. That code first, refine later idea.
Yeah, they pointed out that the speed of vibe coding aligns well with agile principles. You can generate a basic version of a feature very quickly, get it in front of users or testers, get feedback, and then iterate.
So it helps with rapid prototyping and iteration cycles.
Exactly, it fits that model. But crucially, IBM also stressed that human oversight is still absolutely essential.
For what aspects?
For creativity, for ensuring the code actually meets the real goals, not just the literal prompt, and for coming up with truly innovative solutions, the kind of out-of-the-box thinking AI isn't really capable of yet.
So AI handles the grunt work of the first draft. Humans handle the refinement, strategy, and creativity.
That seems to be the most effective approach right now. It's about augmenting human developers, not replacing their critical thinking.
Okay, so kind of bringing this section to a close, the message seems to be vibe coding. Super powerful, lots of potential for speed and accessibility, but
But you absolutely have to be aware of the risks. Technical debt, security holes, scalability limits, maintainability nightmares, testing gaps, they're all real possibilities if you're not careful.
especially for maybe newer developers who haven't experienced the long-term pain of those things yet.
Exactly. So the key is a balanced approach. Use the AI, leverage its power, but combine it with rigorous human review, solid engineering practices, and a deep understanding of the fundamentals. That's how you get software that's not just built fast, but built well.
Right. So wrapping this all up then, the big takeaway, vibe coding is definitely a major trend. It's exciting. It can speed things up and lower the barrier to entry.
But, and it's a big but, you have to be smart about it. Proactively manage the risks we talked about. Tech debt, security, scale, maintenance, testing. They don't magically disappear because an AI wrote the code.
It's about seeing AI as that powerful assistant, like you said, not a silver bullet that replaces good engineering discipline.
Absolutely. Critical thinking, code review, security awareness, planning for maintainability and scale those skills are arguably becoming more important, not less, in the age of AI code generation.
Which leads to maybe a final thing for everyone listening. As these AI tools get even better, even more capable, how does the job of a software developer change?
Mm-hmm.
What are those truly fundamental skills, the core knowledge that will always be essential, no matter how good the AI gets at spitting out code?
That's the big question, isn't it? Something to definitely keep mulling over as you navigate this evolving tech landscape.
Definitely food for thought.
And if you want to dig deeper after this, maybe check out some of the tools we mentioned: ChatGPT, Copilot, Claude, Cursor, SonarCube. And searching for terms like AI technical debt or responsible AI encoding will surface a lot more detailed discussion.
Great suggestions. Well, thanks for taking this deep dive into vibe coding with us today. We hope it gave you a clearer picture, the good, the bad, and the things to watch out for.
Hope it was useful.
Stay curious, keep learning, and we'll catch you on the next one.